Hello, very good morning to all of you. So, dear friends, we were discussing the food analysis, and in that, the name of the topic or chapter is lipid analysis. In half portion of this lipid analysis, we have seen the how to extract that lipids from the food material. What are the different methods available? Okay, that we are seen. Now in this half portion of this chapter, we are going to see the characterization of lipids. So this characterization of lipids means what are the different modes of characterization, means analysis, in the form of iodine value, then acid value, then peroxide value, then saponification value. All these values that can be determined by using some small experiments or small determination that we are going to see. So let us see one by one. So this is the first one, iodine value. So we know that iodine, iodine is exist in a diatomic molecule I2, and this I2 is very useful for the determination of unsaturation. So we know that in organic qualitative analysis, when we do a reaction, that is CH2 double bond CH2, whenever there is a presence of unsaturation in the molecule, and when we add iodine molecule, that is I2, okay, what happens here? Addition of this I2 takes place along this, across this carbon-carbon double bond, and we get CH2I single bond CH2I. So the presence of unsaturation is necessary to add the iodine molecule in this substrate, okay, and this concept is utilized to determine the iodine value in the food sample. Okay, now we have a fats or lipids, and what is the iodine value of that fat or lipid, that we have to determine. So for this method, what is the principle? So iodine value is the measure of unsaturation present in the given compound. Here our compound of interest is lipids or fats. Okay, so that's why here what is the amount of, or what is the percentage of unsaturation, that is carbon-carbon double bond, present in the given lipid or fat, that we are going to determine by using this iodine value. Now what is the definition of this iodine value? Iodine value is defined as grams of iodine per grams of iodine absorbed per 100 gram of lipid sample. So this is the definition of iodine value, gram of iodine absorbed per 100 gram of lipid sample. So this is the definition of iodine value, okay, IV. Now procedure. What is the procedure for this determination of iodine value? We have a lipid sample that is extracted in a particular solvent, generally ether or petroleum ether or hexane or heptane, okay, and take a specific amount of that lipid sample, then use either I2, that is iodine, or ICl, or you may use in some cases IBR. So iodine chloride or iodine bromide or simple iodine molecule, diatomic iodine molecule, can be used for this reaction. So this alkene, when our lipids or fats having carbon-carbon double bonds, so that iodine is get added across that carbon-carbon double bond. So that's why the same reaction we have written here, ICl here in this case it is taken. So ICl, it is taken in excess and it is reacted with this carbon-carbon double bond, that is alkene, okay, and When this addition reaction takes place, we get R CHI single bond CHCl single bond R. Okay, so this is the addition compound plus ICl. So this ICl is remaining ICl after reacting a specific amount of iodine chloride with this alkene. So remaining alkene is here. So remaining iodine chloride here will be here. Okay, then that remaining iodine chloride is then reduced into I2 by using potassium iodide. So potassium iodide is treated with this ICl. It is then reduced to I2 value, I2, and then for the balancing of reaction we have taken here Ki and KCl. Okay, Ki plus KCl. Now this liberated iodine is then titrated against sodium thiosulfate. Liberated iodine is then titrated with sodium thiosulfate in presence of starch indicator. When we add starch indicator in a mixture of iodine and sodium thiosulfate, our solution becomes blue in color. Our solution becomes blue in color, and when the reaction between them takes place, okay, and we are converting this iodine into sodium iodide plus sodium persulfate will be formed. Sodium persulfate will be formed, and the starch indicator is changing its color from blue to colorless. So this is the end point of this reaction. Okay. Now calculation. How to calculate the iodine value by using this procedure? So iodine value is equal to. So what is iodine value? Weight of iodine absorbed or required per 100 gram of lipid sample is equal to B minus S into N into 126.9 divided by W into 100. So what is B? B is the volume of titrant. So sodium thiosulfate is the titrant. Volume of titrant for blank solution in ml. In ml, milliliter. Volume of titrant, that is sodium thiosulfate, for blank solution in ml. Then this is S is volume of sample, lipid sample in ml into N. N is the normality of sodium thiosulfate into 126.9, which is the molecular weight of iodine, I2. Okay, molecular weight of iodine is 126.9. W is the weight of sample and into 100. Okay, so we are converting that iodine value in a percentage. Okay, so this is the method for the determination of iodine value of a food sample which is present in a fat or lipid. Okay, now the next value is saponification value. Next value is saponification value. Saponification value is also known as saponification number. Saponification value is also called as saponification number. Saponification value is also known as saponification number. No. Okay. So what is this saponification? We know that. What is saponification? Saponification is nothing but the ester hydrolysis. Our lipids are in the form of triglycerides. Triglycerides means these are the triesters of glycerol. Okay, so this is glycerol, CH2OH, CHOH and CH2OH. This is the molecule, we call it as a glycerol. This is a triol, 1, 2, 3 triol. 3 hydroxy groups are present, adjacent carbon atoms. When these hydrogen atoms are replaced by the fatty acids, okay, when these protons are replaced by the fatty acids, long chain fatty acids, R1COOH, R2COOH and R3COOH, then by the condensation of this alcohol, that is hydroxy from glycerol and carboxylic acid functional groups from these long chain fatty acids, we get this moiety, and this is called as triglyceride. This triglyceride is actually a triester. Triglyceride is actually a triester, and when this triester is hydrolyzed by using KOH, okay. So potassium hydroxide is the strong base. It is aqueous potassium hydroxide. It is used for the hydrolysis of this ester linkage, and hence we get CH2OH, CHOH and CH2OH. Okay, so this glycerol molecule will be obtained, and along with that potassium salt of these fatty acids we are getting K plus O minus COR1 plus K plus O minus COR2 plus K plus O minus COR3. So this is the mixture of potassium salts of long chain fatty acids which are derived from this hydrolysis or the saponification. This reaction is also known as saponification of triglyceride or lipids or fats. Okay, and this is nothing but a alkaline hydrolysis of fats or alkaline hydrolysis, basic hydrolysis of lipids is known as saponification reaction, and from this reaction we can determine the saponification value or saponification number for that fat or lipid present in the food sample. Okay, now what is the use or what is the definition? The definition of saponification value is milligram of KOH required to hydrolyze, milligram of KOH required to hydrolyze per gram of triglyceride, per gram of triglyceride. Okay, this is saponification value. Now procedure. So what is the procedure? We have a alcoholic potassium hydroxide solution, alcoholic KOH solution is there. Alcoholic potassium hydroxide is added, okay, to this fats or lipids with a particular amount of fats or lipids, okay, and this mixture, this KOH mixture, alcoholic mixture, alcoholic KOH and this triglyceride, that is fat or lipid, is heated. Then after heating we are getting this, okay, and then this liberated fatty acids, when then it is treated with a titrated with a standard SCl solution, okay, or the SCl solution which is having fixed normality, okay, and this is nothing but a salt, or in acidic condition it will be converted into RCOOH, that is esters, fatty acids are converted, they are converted into fatty acids, and these acids are then titrated with the SCl, okay. So the remaining KOH by the reaction of this, the remaining KOH is then titrated with the SCl, and then calculation is done. So the calculation is done in this way. Saponification value or saponification number is equal to S minus B into N into KOH having 56.1, molecular weight is 56.1, S minus B into N divided by W. So this is the formula to calculate the saponification value. Saponification value is equal to S minus B into N into 56.1 divided by W. Okay, so by in this way we can determine the saponification value or number for this fat content. Okay, now the next characterization is the acid value or free fatty acids. Free fatty acids, they are designated by a FFA, free fatty acids. Free fatty acids, that is FFA, and acid value. Acid value. Okay, so the principle. So what are free fatty acids? Free fatty acids are in the form of the fatty acids which are free in form in the lipids. Okay, the fatty acids which are in free form normally reflect the amount of fatty acids hydrolyzed from the triglycerides. Amount of fatty acids that hydrolyzed from the triglycerides. Okay, so it indicates the FFA, free fatty acids. Now what is acid value? Acid value. Acid value is the milligram of KOH necessary to neutralize free fatty acids. Milligram of KOH is the base and free fatty acids are the acids. Okay, so this amount of KOH required or necessary to neutralize free fatty acids, this value gives you the acid value. Okay, now determination of this free fatty acids or acid value procedure. So neutralized alcohol, neutralized means the ethanol which is neutralized already, 95% ethanol, neutralized 95% ethanol is then it is used, and in that phenolphthalein indicator is used. Phenolphthalein indicator is added. Okay, and KOH, sorry, NaOH is used. NaOH. Okay, all these are titrated with this. So if phenolphthalein this is acting as an indicator, this is a base, this is a neutralized ethanol is a mode of solvent. Okay, for this, and the acid value can be calculated by percent FFA is equal to percent free fatty acids is equal to V into N into 282 divided by 282 divided by W into 100. So this is the formula to calculate free fatty acids. So V is the volume of NaOH titrant in ml, N is the normality, 282 is the molecular weight of oleic acid. Okay, so this percent free fatty acids in the form of on oleic acid base. Okay, so this is the molecular weight of oleic acid, W is the weight of sample, and 100 is the multiplying factor for to get conversion into percentage. Okay, so in this way this free fatty acid content or the acid value can be determined. Okay, so these are the three characterization. The remaining characterization we will see in the next lecture. Thanks for watching this video. Have a nice day.